Hello everyone. Welcome to our final push, all right, for your chemistry paper 2. Okay, at the time of this recording, your chemistry paper 2 exam will be tomorrow morning. So all the best. All right, so I've selected a few questions under each topic to help you. All right, some are difficult, some are not. All right, so if you have any, so there are simple rules to this live YouTube video, right? Do try to participate. Please only nice and helpful comments. All right, and if you have a question, okay, please ask. I will definitely try my best to help you. Um, yeah, so let's get started. Okay, let's get started. Okay, yeah. Miss, I can't find my thing to change my slides already. When I click on the image slideshow. Oh, okay. Yeah. All right. So we will start with topic number 2, experimental techniques. Now, this is just basic information. It's either you know or you do not know. So let me know what you think in the live chat. Yeah. So whenever you have a certain substance, in this case water, and you have impurities in the water, what will the impurity do to the melting point and the boiling point? Very good. Okay, so you will know that the impurity will push the melting point down and it will push the boiling point up. So in this case, the correct answer is D. So what a great start. All right, if you have any questions, please ask. We will move on because I did select quite a lot of questions for us today. Okay, another simple one, yeah, just for the sake of putting it under this topic, all right, so you know this topic, the particulate nature of matter is more of diffusion. So what do you think? All right. So for this question, right, it's diffusion, all right? Yes. So the molecules, all right, they will spread further into the air. So for this question, all right, the answer is C. All right, simple question. Moving on. Okay, this one requires a bit of reading, so let me know what you think. So I hope you all know what the RF value is. All right, it's distance moved by the substance divided by the distance moved by the solvent. So for this question, yeah, let's analyze them one by one. Okay, A. So A, B, C, and D. Di W is nearest the solvent front. That is not true, right? Okay, so if I could draw, So I'm going to now draw the baseline, and this is the solvent front, and this is the baseline. Okay, all right. And if your RF value is 0.15, you are most probably going to be around here. So this RF value will be 0.15. And if your RF value is 0.5, you are halfway there. All right. And if your RF value is 0.91, you should be somewhere there. So that's how we know A is absolutely wrong, because W is nowhere nearest the solvent front. B, dye X has traveled furthest up the chromatography paper. That is absolutely wrong, because X is here. Okay, so B is absolutely wrong. Y is present in all. Dye Y is the only dye present in all three mixtures. Well, it is correct, but I mean, it is present in all three, but it is not the only one. So the word only there made it wrong. Okay, I hope that is clear. So dye Z is nearest the solvent front and is found in only two of the mixtures. So that is why D, all right, is correct. So you can see it's a very close call between C and D. So I hope this is clear. If you have any questions, please write them down. Wow. So we have a lot of new friends here, yeah? So thank you for watching. All right, and do participate. Okay, I'm so happy to meet all of you, and I think we have some live streamers on Instagram and all. So welcome to all of you. So if you have any questions, I can only handle questions from YouTube. Yeah, moving on. All right. What do you think about this question? Let's look at the first one. Right? RF values are always less than 1. Yeah, that is correct. Yeah, because you're always dividing it by the solvent front, and nothing can move further than the solvent. So 1 is correct. So automatically you know that C and D, they are wrong because 1 is correct. So that's how you eliminate, right? Eliminate the wrong answers, right? RF value, and you know that number 2 is wrong, which is how you know that the answer is automatically B. Alright, so pretty straightforward, but remember, once you find out which one is wrong, immediately you eliminate. Yeah? Right. Moving on. Okay. Also, another good theory question to test your knowledge. This is purely knowledge, yeah? There's no application. Alright. So I hope you know that when it comes to lattice structure, how many kinds of lattice structure are there? Okay, you have the metals, you have the giant covalent or macromolecules, and what is the last one? All right, what is the last one? Correct, they are ionic compounds, which is why the answer for this question is A. Well done, everyone. Well done. Well, I see you all are very ready for the exam tomorrow morning. Yeah. Yes, giant lattice of oppositely charged ions. So I hope you all know what lattice structures are. All right, they are structures. Okay, and they have a regular repeating pattern of particles. So the particles are orderly and the structure is repeating. So there's a certain order to things. So please remember the 3 lattice structures, yeah? Metals, giant covalent, and ionic compounds. Right. So remember we talked about this I think 2 days ago. So chemical properties are mainly dependent on, let me know what you think. Chemical structures, absolutely right. B, okay? It depends on the valence electrons. So chemical properties, they purely depend on the valence electrons. Absolutely. Okay, let's move on. Right. What do you think? What is the answer? So remember how we draw the structure of silicon dioxide? So we will firstly start with an oxygen and then to silicon and then oxygen, oxygen. So remember this is a tetrahedral structure, all right? You can really only appreciate, the shape in 3D. Okay, so silicon and oxygen, oxygen, and oxygen. So the question is how many silicon atoms, okay, are bonded to each oxygen atom. So one oxygen atom, you get two silicon atoms. So the answer for this question is B. That's right. Are you all finding the questions easy or just okay? Aha, some of you will be stuck here. All right, some of you will be stuck here. Take your time, try out the questions. So I'm going to assist you by writing out the equation, or most probably the equation itself will already give you the answer. So CXHY plus oxygen. So this is the combustion of organic compounds in general. So you're going to get carbon dioxide and water. All right, so what do you think? Have you all tried it out? Mushiga says it's C. Okay. Mushiga says it's C. Well done, Mushiga. I think you are right. Okay. All right. So you have 10 centimeter cubes, okay, of the hydrocarbon, and then you form 20 centimeter cube and 30 centimeter cube. So with water, you've got to be a bit careful with water. So with water, you've got to be a bit careful. But since they say that it is water vapor, so it's a gas. All right. So now that it is a gas, then the moles and the volume, all right, the moles and the volume ratio is proportional. All right. So we'll take this as 1. 10 represents 1 mole, 20 centimeter cube represents 2 moles, and 30 centimeter cubes represent 3 moles. Right. This means that there are 2 carbon atoms, so it will be C2, all right, because there's 2 carbon atoms. And let's look at our hydrogen atoms. So we have 6 hydrogen here. Right? So if we have 6 hydrogen here, it will be C2H6. And that is why the correct answer is C. Alright, and if I were to balance the equation, can you all try to balance the equation? Can you please put the correct number here? Okay, put your answer in the chat. Let me have a look. What do you think is the correct number to put there to balance the entire equation? Thank you. There's so many of you watching. Yeah. What do you think? What number should we put there to balance the entire equation? Anyone want to give it a try? Okay. So if I were to fix the moles of ethane at 1 mole, in that case, the number here will have to be a fraction or a decimal. So in this case, you have 7, all right, you have 7 oxygen atoms on the right, 7, all right, you've got 4 plus 3, 7. So, and there's an oxygen molecule here is O2, so the answer is 7 over 2 or 3.5. So if you fix this at 1 mole, right, then you will need to have a fraction or a decimal. So I hope this is clear. A lot of you are pretty quiet here, so I think you're facing some struggles. Do you have any questions here? Please ask. Else I will have to move on. Yeah? All right. Another question. Well done. Next question. Fantastic, Catherine. The YouTube, I forgot to put ultra low latency lah just now. All right. So the formula for this question is concentration equals to mole over volume. So the concentration is 0.2, the volume is what they are asking. So you need to change 4 grams into moles. Is that clear? Concentration is mole over volume, right? Concentration is mole over volume, right? So, how do you change 4 grams into mole? Well, mole equals to mass over mR, right? So, the mass is 4, and for sodium hydroxide, it is 23 plus 16 plus 1. Alright, is that clear? So 4 divided by 40 is 0.1 moles. So there are 0.1 moles of sodium hydroxide. So you move the moles here, 0.1. So volume equals to 0.1 divided by 0.2. Okay? So you've got 0.5 decimeter cube, which is 500 centimeter cube. So the answer is C. All right. Anyone has any problems calculate any questions regarding this question? I'm going to pause here for a while. So any problems with this question? So if any of your friends are free now, please get them to join our live stream. All right, so that we can help each other out for your exam tomorrow morning. Huh? Okay, so the answer is C. So please let me know if you are having any problems. Okay. Now we have to move on. So remember, if you have any problems with the previous questions, all right, just let me know, and yeah, I will try to answer them. All right, another concentration question. All right. So I think with what I've done just now, I think more or less you all can do this, right? So concentration is mole over volume, all right? So 25 grams, you need to change to moles, and then the volume, you've got to change to decimeter cube. So I hope you know that centimeter cube to decimeter cube, you need to divide by 1,000, all right? You need to divide by 1,000. So there we have it. So it's sodium hydroxide again. So it's 25 divided by 40. So that will be 0.625 moles divided by 0.5. Correct or not? Huh? So 25 divided by 40. So divided by 0.5. So it is 1.25 moles per decimeter cube. So in this case, the answer is C. Don't forget to convert from decimeter cube to centimeter cube, and the other way around whenever you need to. Well done to those who are trying. Very good. Okay, do you have any other questions for this particular past paper? So remember, when you're practicing your past papers, yes, it is important to it is important to, what do you call, it's important to attempt the questions that are from recent past years, but it's also very important to do the old past years, the pre-2016 past years, because I found on more than several occasions that they have taken questions from the old past papers into the new question papers verbatim. Some of them, they are verbatim, so please remember to attempt questions from the old past papers. Any questions regarding stoichiometry and concentration at this point in time? Yeah, no, huh? Okay, I'll move on. Okay, have a go at this question. Okay, what do you think this question, what do you think the answer to this question is? D. Yeah. C. C and D. All right, for this question, the answer to this question is C. Now, let's discuss why that is so. For question A, oxygen gas is produced at the positive electrode. That is not right. What happens at the positive electrode? All right. What happens at the positive electrode? Let me know. What do you think happens at the positive electrodes? Okay, do type it down. What do you think happens in the positive electrodes? Very good, Mushiga. Copper electrode dissolves. So you're going to get copper ions from the positive electrode. Well done. So oxygen does not, it's not released there. The blue color of the solution gradually fades. Well, that's not true. That's not true. That's not true because from the anode, you're going to get copper 2 plus, and at the cathode, the copper 2 plus, they are going to form atoms. So the concentration of the solution stays the same, so there's no change to that. And the mass of the negative electrode does not decrease. In fact, it's going to be collected with copper atoms, a layer of copper over there. So D is wrong. So I hope you are clear. Moving on. Any questions? Please put them down. A fuel cell is a cell, guys. So what do you think the answer to this question is? Yes, very good. Okay. So this is a pretty straightforward question. It's a fuel cell, so it produces electricity. Yeah, so it produces electricity. So you have A, B, C, and D. So the answer is D. Now, so it's not heat, yeah. But B, fuel cell is supplied with hydrogen directly from the air. Please, guys, the air does not contain hydrogen, nor does it contain helium. So that's why B is not the answer. And we haven't learned of any emissions resulting in nitrogen gas. So this is absolutely ridiculous. So for this question, the answer is D for this question. All right. Moving on. So very straightforward lah. Fuel cell is electricity, all right? Yes, Mushiga, they release energy, but electrical energy, all right? Next question. Okay. Now, you need to remember that all right. Okay, students from AISS, I do expect to see you participating more actively, especially the year 12 students, right? So I hope you know that these are the reactants and this is bond breaking. So bond breaking is endothermic and they need to happen at the left side, right? And this is bond forming. So bond forming is an exothermic reaction. So if this reaction overall is exothermic as explained by the question, all right, therefore the there will be more energy released during bond forming. So the answer to this question is very straightforward. Yes. Hello, Huting. Nice to see you again. It's C. Okay? So, straightforward, huh? Okay. So, yeah, give me a second. Okay. Uh, do remember that I've told you that if one way to tell that a process is endothermic, that it needs to be heated up. Okay. So, which one of these process do you think needs to be heated up for the process to continue happening? Most of the time, neutralization is exothermic. Most of the time, yeah. So the answer to this question is C. Okay, so solid, liquid to gas. So remember, solid to liquid, liquid to gas. These are endothermic reactions because heat needs to be supplied. The substance need to absorb heat. So that's why it's an endothermic reaction. And condensation and freezing, they are exothermic. If you did not know this, please note this down. Moving on. Okay. Uh, okay. Okay, Ian, you think it's B, yeah? Okay, sorry for the delay, yeah? Okay, all right, so if it's endothermic, right? So if it's endothermic, then the energy graph will look like that. So the energy of the products in the neutralization reaction is greater. So number one is correct. Okay, the energy of the products is greater because it's endothermic. Number two, displacement is exo, all right? So the energy of magnesium and carbon dioxide is greater, correct? Because the exothermic, so this is endo and this is exo. So the exothermic graph, yeah, so the energy of the magnesium. So number two is also correct, okay? Number three, in an exothermic reaction, the energy required to break the bonds, okay, is greater, so this is wrong. It is the other way around. In an exothermic reaction, the energy released during bond forming is greater. So the answer to this question is B. All right. Okay, let's move on. All right. There's an important point to this question. Okay, remember that of course paper 4 is all over and done with, yeah, but you know, up to the preparation for the paper 4, all right, students, I hope that you have um, place some priority on talking about activation energy when the rate of reaction questions do come out. All right. So remember that when you increase the temperature, not only the particles move faster, there is a higher chance for them to overcome. Okay, there's a higher chance for the particles to overcome the activation energy. So what's the activation energy? It is the minimum threshold energy, all right, that the colliding particles need to overcome. All right. So, interesting question. So, what do you think the answer is? Very good. The answer is C. So, do remember that when you talk about temperature, yes, there are more frequent collisions, but you also need to talk about energy. So, when you increase the temperature, the particles move faster, so there's greater energy. All right. But when you just increase the concentration, you do not change the kinetic energy of the particles. All right. So there, well, just because there's more of them, so they will collide more often. Okay, but the force of collision is not increased. So remember, when you increase the temperature, higher chance to overcome activation energy because the colliding particles have greater energy. So remember that. Okay, any questions, put it down in the chat. Reversible reactions for you? So you will, so immediately you know that A and C are the wrong answers, because you are not going to, because the volume of gas on both sides, they're the same. The volume of gas on both sides are the same. So there will be 2 moles versus 2 moles. Okay? So it's only about temperature. Okay? Um, Okay, so if the forward is endothermic, of course you know that when you increase the temperature, you will help to favor the endothermic reaction. If you decrease the temperature, you will favor the exothermic reaction. So for this question, the answer is this. So what's to learn from this question is that you need to count the moles on both sides. All right. So 2 moles versus 2 moles, it will make a difference. So pressure will not make a difference. All right. Moving on. Okay. So for the next question, you have copper oxide, all right, reacting with a reactant, and you're going to get copper plus something. So what happens? What kind of reaction is this? All right. What kind of reaction is this? Whereby copper oxide becomes copper. Very good. Very good. Thank you for participating, everyone. Thank you. Um, yeah, can you write down what is this? What's the name of this conversion from copper oxide to copper? Let me know. Okay, so this process is called reduction. Very good, Ian. Thank you. All right, Hugh Ting, thank you. So you need a reducing agent. So what's a very good reducing agent? You all know it is carbon monoxide. So you are right, guys. The answer to this question is D. Very good. Moving on. Okay, you know that the cobalt chloride, they are crystals, okay? On the right is crystals, on the left is anhydrous. So you know that, from hydrated to anhydrous and vice versa, that is reversible. And I hope you know that carbon dioxide is not reversible. From carbon dioxide, you cannot get back carbon and oxygen. So this is a very straightforward question. Yeah. So the answer to this question is a C. Okay. Sorry. Yeah, it's a B. It's a B. Sorry about that. Yeah, B. Very good. Very good. Let's move on. All right. Which changes represent reduction? What do you think about this question? All right, good. So I hope you know that 3 is absolutely ridiculous. Guys, can you write down in the chat okay, what do the Roman numerals actually represent? What do the Roman numerals actually represent? Can you write it down in the chat? What do the Roman numerals actually represent? Correct. Not just oxidation number of what? The Roman numerals represent the oxidation number of? Yeah, but it's to represent the oxidation, not just any metals. What kind of metals? It's transition metals only. Transition metals only. So look at sulfate. Sulfate has no transition metal inside. So 3 is absolutely ridiculous. Huh? So remember, the thing to learn is the Roman numerals represent the oxidation number of transition metals. And it just looks ridiculous on the sulfate, right? Moving on. Do you remember? Testing for ions. Do you remember the 3 metal ions? All right. Do you remember the 3 metal ions that B? Are you all sure? No, I don't think the answer is B. Yeah, it's not B, guys. It's not B. It's not B. Yeah. Because if you put barium chloride with aluminum sulfate, you are going to get a white precipitate. And if you put barium chloride with zinc sulfate, you are also going to get a white precipitate. Okay, so using barium chloride, you cannot distinguish aluminum sulfate and zinc sulfate. Okay, yeah. So right, the better answer is Yeah, the better answer is no, it's not even C. It's not even C. Now, can you help me? All right, I'm trying to explain something here. After I explain, the answer will become obvious. All right, which are the which are the three metal ions? Okay, when you add sodium hydroxide to them, you're going to get a white precipitate. And if you add sodium hydroxide in excess, it's going to dissolve. The white precipitate is going to dissolve. Can you please tell me, all right, the three metal ions that will dissolve in excess uh, sodium hydroxide? Aluminium, lead, and zinc. Okay, so these are the three amphoteric. If they are oxides, then they will be amphoteric in nature. Okay, but for ammonia, only one of them will dissolve if you put them in excess. So remember, you're going to get a white precipitate. You put in excess, it dissolves. You add ammonia, you're going to get a white precipitate, and then you add excess, it dissolves. But ammonia only dissolves just one, which is zinc. Thank you, Mushiga. Zinc. So don't you see that if you use ammonia, A is the answer by the way. If you use ammonia, you're going to be able to differentiate aluminium sulfate from zinc sulfate, because aluminium you're going to get a white precipitate that does not dissolve again, and then you're going to get a white precipitate for zinc that dissolves again. So you're going to get different distinct results. Since all of you had trouble with this question, do you want to ask anything? Basically, I think you misread the question, or you were not so aware. You're supposed to use A, B, C, D, one of them, which you can use to distinguish which one is aluminium sulfate and which one is zinc sulfate. Okay? I hope that is clear. Because if you use sodium hydroxide, you're going to get the same result for both of them anyway. You're going to get a white precipitate that and the white precipitate is going to dissolve. Okay, so I hope this is clear. Moving on. Oh, so that was a good question, huh? Fantastic. Moving on. So this one is not an application question, it's a factual question, theoretical question. It's whether you know it or you don't. So if you don't know it, well, just know it now for tomorrow. Okay. It was certain things may just have never been brought to your attention, okay, unless it was and then you forgot about it, right? Yes, the answer is D. So carbon monoxide is neutral, but aluminium oxide is amphoteric. That is absolutely correct. Absolutely correct. Now I got one question here. In your syllabus, there are two oxides that are neutral. What is the other oxide that is neutral? Put it down in the chat. Yes, the answer is D. I want one more oxide that is neutral. I see new friends joining. Fantastic. Water. Very good. So water is of course dihydrogen oxide, right? Water is dihydrogen oxide. It is an oxide. So water, no, nitrogen oxide is acidic ion. So water and carbon monoxide, they are the two neutral oxides in your syllabus. All right. So please note. Next question. Okay, more on testing for ions. Okay, I think the question before this would really help us, right? So since you get white precipitate, yeah, Mushiga, well done. Yeah, since you get white precipitate that dissolves, automatically you know it is zinc. All right, so automatically you know it is zinc. So the fact that you know it is zinc means it's either C or D. And of course, hydrochloric acid reacts with carbonates. All right, so I think the question before this really helped us. Anyway, very good. Next question. You don't have to just put the answer down, guys. Remember, if you have any questions, you can ask. Yeah? Interesting question. Interesting question. This one. This is quite an interesting question. It's not difficult. I don't think it is, but you know, it will evoke certain response. Right? Let me know what you think. Hello, Jashan. Okay. Thank you for participating, everyone. Yeah, thank you, Jackie and XC. Yeah, all right, thank you. Now, Ian, lagi best C or D? The answer is C. Okay, now you got to understand that sodium hydroxide aqueous mean solution is actually made up of sodium hydroxide, which is an ionic compound, and water. So in distillation, one of them will have to boil first. I hope you know that ionic compounds, they have very much higher boiling point compared to water. So water is going to be obtained in the beaker on the right, which is known as the distillate. Okay, and this is what is going to remain. And you know, water pH is 7 and sodium hydroxide, the pH is 14. So therefore the answer is C. So what is to bring home from this question is this: sodium hydroxide, being an ionic compound, has a much higher boiling point than water, so it's going to remain in the flask for a longer time. Yes, water is distilled first because of the lower boiling point. Very good. Let's look at any other questions. Okay, again, this is an understanding question. All right, so it's whether you know it or not. Let me know. Okay, very quickly, Ian managed to get the answer. Okay, so I hope you know that you know, when you learn acid and bases, you've got strong acids, weak acids. You've got strong bases or strong alkali, weak alkali. Weak base and weak alkali, there's only one example that we taught, all right? It is actually ammonia. So automatically you know, all right, that you are looking at weak and weak. Okay, now look at the ammonia. Look at the ammonia. What happened to the ammonia? Yep, and you know that ammonia accepted, look, so ammonia was NH3 and it became NH4 plus. So what happened was it accepted a proton, and I think you know a proton is essentially a hydrogen ion. So since you accept a proton, so you are a base and not an acid. So the answer is D. So remember, ammonia is a weak base, you learn, but just to confirm, you actually see the ammonia accepting a proton. Very good, Mushika. Let's move on. So you're going to have copper, you're going to have zinc, and you're going to have zinc oxide. And they are all going to be reacted with sulfuric acid. So what is the result? Okay, the result is you're going to get copper sulfate and you're going to get zinc sulfate. Is that right? Is that right? Is that right? Is this what you are going to get? Can we have a little discussion over there? Will this happen, guys? Will this happen? You think, thank you for your answer. But all right, any comment about what I've written here? A is not the answer. Actually, what I've okay, Mushiga. Actually, what I've written there is wrong. You all have to remember one thing. Please open your ears. All right? It's wrong. A is wrong, guys. A is wrong. Okay? A is wrong. No, it's wrong. What I've written is wrong. Because you need to, please open your eyes and your ears. Copper does not react with acid in IGCSE. Copper does not react with acid in IGCSE. So you're going to get um, a pink solid and a colorless solution, and the answer is B. I hope you have learned something. Remember that copper does not react with acid. So you don't get a blue solution, okay? No, the answer is B for boy, yeah? B for boy. Okay, so I hope you know that acidic oxides, okay, acidic oxides are non-metal oxides, yeah? So acidic oxides, they are non-metal oxides are acidic oxides. So we are talking about a non-metal. So a non-metal, yes. Guys, pink, is copper. Rohan and Huting, pink is copper. Okay, let me re-emphasize this. In IGCSE, copper, you can describe it as pink, you can describe it as brown, or even light red brown, but pink is highly accepted. Okay, it's a highly accepted color of copper in its element form. Pink is copper. I hope that is clear, right? Yes, the answer for this is D, because if your valence electron is 6 and 7, you are a non-metal. So the answer to this question is a D. Keep the questions coming. Yeah, whatever you are not sure, just ask. Okay, Rohan, you think pink is copper. Moving on. Okay, a lot of students are very confused when it comes to the decomposition of salts. Okay, when you heat the salts up, what do you get as a result? So this will serve as a, not difficult, but it will serve as a good point of revision. Okay, it will serve as a good point of revision. So if you did not know, magnesium nitrate, okay, when you heat it up, you're going to get magnesium oxide, you're going to get nitrogen dioxide, and you're going to get oxygen. For magnesium hydroxide, you're going to get magnesium oxide plus water, okay? And for magnesium carbonate, you're going to get magnesium oxide plus carbon dioxide. So from here, very automatically, you will know that the answer is C. Right? Guys, do you agree with me? Yeah. Are you okay? Are you following fine? I seem to have lost you in this question. Can you let me know if you're okay? All right, moving on. So, see, yeah, moving on. Oh, we are now in topic 9. Remember, there are 14 topics. Okay, I hope to finish this soon. All right, and basically, this is not a difficult question, but just let me see whether you know the answer or not. Yeah, let me know the answer. Yeah, okay. So remember that transition metals are dense, they have high melting boiling point, they are stronger and harder, and yes, they do form colored compounds. Okay, so nothing difficult about this question. I just wanted to make sure that you all know that, right? They always compare transition metals with group 1, which are softer and have low density. Anyway, let's move on. All right, topic number 10, which represents an alloy. A solid alloy. Yes. Uh, in that case, can you tell me what A and D is? Can you tell me what A and D is? What is A and D? Tell me what A is and what D is. Yep, the answer is B. Thank you, guys. Can you let me know what A and D is? What do you think A and D is? So I selected this question because I want you to let me know what A and D was. Okay, D is a mixture. Is it solid, liquid? Yeah. What kind? Yeah. So if you combine Mushiga and Ian's answer, it's good. It's a liquid mixture. What about A? Yeah, it's a liquid mixture. It's important to have the word mixture there. Let me know what A is. Please don't tell me that A is a solid, right? I know that A is a solid, but a solid what? Can you give me more information? Correct. So A is a solid ionic compound. Well done. Well done. Well done. Thank you, guys. Uh-huh. Give this a go. Alright, so the fact that Z reacts with the ion of X means that Z is more reactive than X. The fact that Z reacts with W means that Z is more reactive than W, so you do not know where W is. But the fact that X is more reactive than W means that W is down here. And finally, Y is more reactive than Z. So the answer is, let me see, what did you all get? Oh, no one has put anything yet. All right. Anyone has difficulty with this question? From the ionic equation, do you know how to see which is more reactive than the other? Anybody wants to ask any questions here? Yeah, the answer is C. But more importantly, my question to all of you is this. Can you all tell from the ionic equation which one is more reactive than which one? So take for example the first line. Z reacts with O. Okay. Thank you, Mushiga. So I'll explain, yeah. So for example, you see that, look at the first one. Z plus X2 plus, you get Z2 plus X. Okay. So you know that Z reacts with the compound X. Correct? So Z reacts with this. So Z takes his place. So Z displaces X from the compound. So there was a compound, but Z displaced and X got out. For example, it could be anything. It could be anything. For example, it could be chloride. And then you're going to get a Z chloride plus X. So from here you can see that Z displaces X. This means that Z is more reactive than X. So I hope this is clear. Yeah. So when you displace somebody from their compound and you take their place, you are more reactive, okay, than that ion component. Moving on. Okay, Mushiga, I hope that's okay. If that's still not okay, please type down a more specific question. Okay. Now, is the extraction of zinc. I purposely find this question because I purposely looked up for this question because the extraction of zinc rarely comes out, especially in paper 2. So this is one of the very, very few questions. So extraction of zinc, there are two parts. Okay, let me see whether you all can get the answer for this question or not. A. Wow. So yep, A is the answer. What about the second part? Since you all know that this is the first part, can you let me know which one is the second part? So the answer is A, yeah? So which one is the second part to the extraction of zinc? Yeah, C is the second part. So very good, Dion. Absolutely good. So A and C. So this is the first one in the extraction of zinc, and C is the second one. No, it's not. It's not D. It's not D. Yeah, it's not D. The second one is C. So zinc two parts, A and C. After that, you will know. Huh? All right. Moving on. Okay, this is a question that a lot of students find it very difficult to understand. Let me know what you think. The topic which this question is under should give you an understanding. What about the answer to this question? Can you all get it? So the question is, which component of air will copper react with? Which component of air that copper will react with? Do you know which component of air? No, it's not A, Jiashuan. Thanks for trying. Do you know which component of air copper will react with? That's my next question. Do you know which component of air that copper will react with, guys? All of you. Do you know which component of air copper will react with? Oxygen. You think very good. Yes, it's oxygen. And oxygen represents like 20% of the total air volume, right? So the amount of air, the total amount of air, the clean dry air on the left is 100%. Alright, so if you have 30 centimeter cube here, then you just multiply this by 5, you get 150 centimeter cube. So the answer is C. Are you all clear? Anyone has any questions here? Right? Some questions will ask you, alright, listen here. Some questions will ask you what is the amount of air that would be left over on the right. Yeah, how much, what is the volume of air, that will be collected on the right after the piston at the left has been pushed into the maximum point? Well, so the answer is 120. Thank you that this is clear. Let's move on. Don't overthink this question. Yeah, this is a very straightforward question. Don't overthink it. Okay, let me know what you think. What is the answer? So you all know that the screw will corrode. So the screw will be the less reactive metal. Okay? Sorry, the more reactive metal. The screw will be the more reactive metal. Remember, more reactive metal, they are usually more corrosive. All right? Okay, guys. Yeah, all of you are wrong. Huh? All of you are wrong. It's not D. Yeah. You see, the reason why I chose this question is this. Because many of you will be thinking, because aluminium got aluminium oxide, ma. Yeah, aluminium got aluminium oxide. So it cannot be that the screw is aluminium. The answer is actually A. Okay, because you all brought in aluminium oxide, right? Which is why you all chose the answer as D. Okay, but don't overthink this question. Aluminium is more reactive than both steel and copper, so aluminium will corrode. So the answer is A. Don't bring in aluminium oxide. I know you, yeah, this question is not so fair because what about aluminium oxide, right? I know, but I checked the mark scheme and yes, you don't overthink this question. The answer is A. Moving on. All right, this is another question that you need to think carefully. Yeah, you don't just choose the correct answer. You choose the a realistic, the best answer. What do you think about this question? Let's see more answers first before I comment. It's one of the huge structure, all right, that is part of the bridge. It's the point is it is huge. Okay, now the answer to this question, all right, is actually okay. The answer to this question is actually D. Now, the iron girder is a huge structure, and please, you're not going to grease up part of the bridge, right? It's going to be slippery and it's just not practical. Yes, coating it with grease, electroplating and painting can prevent the rusting, but it is not being done in real life. You can't coat an iron girder with grease, and you can't we can only electroplate small items. Usually they are, like jewelry. We electroplate jewelry, yeah, so that yeah it looks good, yeah, so it's expensive, so we don't electroplate an iron girder. So usually for the bridge and all, we will just paint it. So the answer is D. So this is the reason why I chose this question, because it requires some thinking. It's not just choosing the correct answer, but if the correct answer is not being played out in real life, we don't choose it. So the answer is D. You just paint it, because the other two, coating it with grease and electroplating, is just not practical. Okay, moving on. So the answer was D just now, yeah? Oh, see, this question caught all of you, huh? Okay, the next question, please. Correct. So, yeah, the answer is C, correct. So, decomposing vegetation. Yeah, what is the air pollutant caused by decomposing vegetation? Write it down in the chat. What is the air pollutant released by decomposing vegetation? So the answer for this question is a C. Well done, it's a C. Yeah, but I want to know what is the air pollutant released from decomposing vegetation. Methane. Very good. Very good, all of you. Okay, you all know this question. Very good. Moving on. Okay. Quite straightforward. Let's just quickly get this over and done with. What do you think the answer is? Yep, the answer is B. So the last one is mixing, because alloy is a mixture. Alloy is a mixture. Okay, very good. Thank you. I love to see all of you participating. Yeah, so absolutely right. Let's quickly move on. All right, now I just put this here for the sake of putting it here because it's not so easy to find a question under this topic. Very quickly, hammer down the answer. Come on. Your Rohan, your door hinges. Okay, a very, yeah, basically hinges lah. Huh? You would just grease it so that when you open the door, it will make less noise. Yeah. Because when you grease something, right, it's so disgusting, right? You're going to make sure you don't touch it, right? So yeah, door hinges, absolutely. So this is sulfur. Okay, so this is sulfur. Remember the three uses. Bleaching agent, usually we bleach wood pulp. Killing bacteria, we use it in food preservative. And manufacturing an important acid, which is sulfuric acid. And I hope you remember the name of that process. It is contact process. So the answer to this question is D. Let's move on. Again, under carbonates you get the carbon cycle and you get this. All right, so very straightforward for this topic. Yeah, in fact, teachers usually don't teach this topic because it's too straightforward. Anyway, hammer the answer down in the chat very quickly. Let's go. Yep, absolutely right. It's just the decomposition of calcium carbonate. Sorry, you get carbon dioxide plus calcium oxide. So this is the solid, it will move down and the gases will go up. So it's very, very straightforward, right? So it's calcium oxide. Let's move on to the next question. I prepared quite a bit of organic chem today, so I want to get into that. Okay, another carbon cycle question. Quickly, hammer the answer down there. So remember, I put this question in not because it's difficult, but because, you cannot get a very interesting carbonate question. Yes, it's so straightforward. It's basic science. The answer is A. Can we move on? All right. I don't think anyone will have any questions here. Finally, we have organic chemistry, and the reason why I'm choosing this answer is because 2 days ago we did not really talk about homologous series. So I hope you know. Let's do a brief recap on homologous series, right? So the homologous series, well, they all have predictable physical properties. What else? Sorry about my spelling, yeah. You have similar chemical, let me try and spell that word again properly, properties. Okay, you've got the same functional group. What else have I not written? Same general formula. Okay, and each member increases by dash CH2 and the like. Okay, so automatically you know that the 2 is absolutely crazy. All right, you cannot have all members like methane, ethane, propane. You cannot expect them to have the same molecular mass. So 2 is wrong. If 2 is wrong, you are left with A and B. Okay, and you definitely know that ethane and ethene, one is alkane, one is alkene, so 3 is wrong. So the answer is a B. All right, so I chose this question because I wanted to run down a quick recap about the homologous series. Okay, very good. Now let's go on to the next question. Easy but not so easy lah, huh? The next question, give it a go. Wow, that's very good, guys. Okay, so I hope you know. So bitumen is for making roads. So what is used to make waxes? Fuel oil. Diesel is used for diesel engines. Fuel for aircraft is kerosene or paraffin, right? Lubricating oil is, well, lubricants, and to make waxes and roads we use bitumen. So paraffin or kerosene, they are used for stoves, oil stoves. So that's very good. Now the next one. Aha. What do you think this is? Wow, how did you all know? Wow, I'm very shocked. Chauhan D, are you sure? Yeah, guys, A is the answer. A is the answer. Well done. But why not B? What is gas oil? Now, I hope you know that another name for diesel is gas oil. Did you all know that? Okay? Yeah, another name for diesel is gas oil. So B is correct. Okay, so the answer to this question is A. A is not right because fuel oil is for huge ships. The fuel for huge ships and making waxes. All right. Okay, what is used to make waxes is the lubricating fraction. Yes, wax is for lubricating. Now, kerosene is jet fuel and naphtha, yes, all right, it is a feedstock. We use it to make all sorts of chemicals. Gas oil is diesel, you think, not gasoline. Gas oil is diesel. Okay, I hope you learned something today. Moving on. So the answer to this question is A. Moving on. Alright, you don't get cracking very often in paper 2, which is why I am inserting cracking. So for those of you who have not, please subscribe to our YouTube channel, please, and follow us on Instagram and Facebook to know more updates about our events and the happenings in our school. Now, I chose this question because cracking does not come out very often. So let me know what you think. Very good. Very good. So you know that cracking will produce small alkenes and small alkanes, but sometimes you do get hydrogen. Wow, wow, wow. Very good. Very good. I did not expect you all to get this. All right. So yeah, cracking you get small alkene. Cracking you get small alkene. Moving on. Alright, and again, you don't get fermentation very often. So remember, fermentation, you use carbohydrates, and the other way is catalytic hydration, whereby you use fossil fuels. Alright, so what do you think the answer is? Of course, they will always get you to compare catalytic hydration and fermentation, the advantages and the disadvantages. So let's see whether you can get the advantages and disadvantages correctly for fermentation. Very good. The answer is A. It uses renewable and it's slow. Very good. Very good. Oh, Zhao Han coming in and talking a lot, Okay. All right. Let's see. What do you think about this question? Yeah, in case you are wondering, I'm putting next Q there just to separate what was discussed before. If not, I do not know the answer is for which question. So what do you think about the next question? Wow, good, good. So carbon, hydrogen, nitrogen, oxygen. That sounds very much like what is this called, guys? This is called the amide link. So definitely it's polyamide, and definitely polyamide is condensation polymerization, because addition polymerization only happens with alkene. Okay, with alkene. Very good. So if it was carbon and oxygen only, so it's the COO, so it's the ester link, then that would be polyester. Okay, easy peasy. Okay, coming in, spoiling all the fun, Zhao Han? Okay, which row gives the names of ester and the carboxylic acid and alcohol? Wow, so this question wants everything. It wants to know the name of this ester, and it wants to know the reactants. So I hope you remember that this is the acid and this is the alcohol. By now, you definitely need to remember the acid. you know, where the acid is and where the alcohol is. Huh? So the acid is the carbon with the double bond oxygen. So that's the acid. And the carbon connected to the single bond oxygen, well, that's the alcohol. So this really, let me see your answer first. Let me see your answer. I need to get the answer first, right? Oh, never mind. BC, BC, BC. Everyone is muddled between B and C. Okay, so of course, right, the name would be ethanoate. Okay, so the back name follows the acid and the front name follows the ester. So it is methyl ethanoate. So it looks like C, guys. So 2 carbon for the acid, so it's ethanoic acid, and 1 carbon for the alcohol, so it's methanol. So the answer is C. Any questions here? So yeah, what's important is for you to recognize which part is the acid, which part is the alcohol. From there, you will know the reactants, and from there, you will get their names. All right. If you are not so sure and you learn something here, very good, because we are going to try the next question, which is very much similar. Wow, the chat is very silent. Wow, the chat is very silent, guys. Very good, Tauhan and Mushiga. The answer is A. Ian is fine. Huh? It's okay to make mistakes. It's fine. Okay, but most importantly, let's learn. Alright, number 1 is ethyl and propanoate. So this will give you C5 as well. Right? Number 2, you've got propanol and ethanoic acid. You're going to get C5 as well. For number 3, you're going to get butyl, which is 4, and methanoic acid as well. So you're still going to get C5, and the fourth one, you're going to get methanol and butanoic acid. You are still going to get C5. So the answer is A. I hope this was clear. For those of you who found this a bit difficult, you can ask questions. Okay, we are moving on. So can you all very quickly write down what type of condensation polymer this is? Can you quickly type down in the chat? So let's see who is the first one. Which one? What is the type of condensation polymer this is? Hey Jackie, you can't retract messages, you know. Whatever is typed is typed. Okay, can you please type down in the chat what kind of polymer this is? Absolutely right, Mushiga. This is a polyester, and an example of a polyester is terylene. Ian, are you sure the answer is A? The answer is not A, Ian. And you know that synthetic polymers, we learned two synthetic polymers, all right, which is terylene polyester and nylon polyamide. The issue is synthetic. All right, I want to make this clear. Okay, synthetic condensation polymers like nylon and terylene, they have only two monomers. Now, this is important because they always they will use protein. Okay, now protein is a natural polyamide, and different to what was above here, it can have more than two monomers. So remember, I hope you remember when your teacher, or to my students when I was teaching this, I told you that synthetic polymers, two monomers only, which is why this part in protein tries to draw a distinction. So protein can have more than two monomers. It can have 3, 4, 5, 6, 7, 8 monomers. I hope this is clear. I hope this is clear. I think that was the last question. If you have any questions, you can type it down. Yep, that was our last question, and that's all from us. Okay, that's all from me. Okay, at Aspiration International, we want to wish all you who are viewing and watching this all the best in the paper tomorrow. Well, if you have friends who are not able to watch this at this time, please, you can send them the link as well, and they can watch it at their convenience. But of course, you who are here, you get to participate in the live chat. All right, so I had mighty fun. I really am enjoying myself, and thank you for participating. All right, so well, if there's no other questions, that's all from us. You can go. And I will, as usual, I will stay back for a few minutes to answer any questions you all have. All right, so the live chat will be on for some time. All right, so if you have any questions, do continue putting it in the live chat. Yeah, so thank you. My name is Mr. Un. Thank you for watching. Okay, really had fun with all of you. Bye bye. Bye bye. Hope to see you in the future.